Alright everyone, so today we're going to look at determining the area of composite figures. So these three images that you see on your screen are composite figures. So we're going to talk about what are composite figures, how to set up and solve a problem involving the area of composite figures. We'll look at some examples and then summarize everything that we've seen. Alright, so what exactly are composite figures? So the word composite basically means to combine. So composite figures are figures that are combinations of other figures. So we're only going to work with shapes that we're familiar with, triangles, rectangles, circles, things like that. So later on when we talk about area of a shaded region, don't confuse the two. Even though they're very similar and how you solve them are very similar, don't confuse the two. All right. And most importantly, know your formulas for a square, a rectangle, triangle, circle. Maybe it's okay that you don't know the formula for a trapezoid because technically a trapezoid is a composite figure, all right? But rectangle, triangle, and circle, these are the formulas that realistically you should already know. You've probably seen these formulas since elementary school. All right, so how exactly do we solve composite area problems? So you want to separate your figures by drawing them separately, and then you want to draw your figure equation, and then substitute and evaluate, and don't forget your units. Alright, so let's take a look at this first problem right here. Alright, so here you can see we have this L-shaped design, or this L-shaped composite figure, and what people tend to do is they like to cut it into two different pieces. So realistically, it doesn't matter how you cut it up. You could cut it up, like this, where you have, this rectangle here and then this rectangle here. It realistically does not matter. All right. So I'm going to cut it here. All right. So I'm going to cut it vertically. And what I'm going to do is I'm going to draw them separately. So I have two rectangles. And what I like to do is, I like to put the formulas for the area of a rectangle inside, just like this. So that's going to be my area. So this is basically my figure equation right here. So underneath, I want to substitute, the values in for the base and height for this particular rectangle. So if I call this, let's say rectangle 1, I could call this rectangle 1. I could call this rectangle 2, and then I could call this rectangle 2. So here we have a base of 3 and then a height of 5. So fill those values in. So we have a height of 2, and not to be confused with figure number 2. So I'll draw that out here. And then the length of my base would simply be the length of this base right here, subtracting the length of this base. So 6 minus 3 gives me 3. So base times height, that's going to be 5 times 3 plus 3 times 2. So I have 15 plus 6 equals 21. And since we're dealing with area, my units are going to be square feet. All right, or whatever your units are, they'll be your square units. All right. So again, this is a simple example, but if you follow these steps, because obviously problems can get more complicated, but if you follow these steps of drawing your figure equation, substituting, and then making sure to tack on your units at the end, once you get into the habit, a lot of the other problems are going to be a lot easier to solve. All right, so let's take a look at this next problem right here. So here, as you can see, we have an equilateral triangle or an equal angular triangle, right? And because all three angles are going to be congruent to each other, I know all the sides are going to be congruent to each other. So here, I notice that I have really two distinct shapes. I have a triangle, and then I have these semicircles. So here, I'm going to draw my figure equation. And then I want to add 3 of these half circles. So instead of drawing 3 half circles, usually what I like to do is just put the number 3 out in front and then draw my semicircles. So I have base times height divided by 2 and then I have pi r squared. But since I have half a circle, I need to take the area formula for my circle, which is pi r squared, and then divide it by 2. Right, so once I've done that, all I realistically need to do is solve my figures. So if we take a look at this triangle right here, right, so we're going to have to do some detective work. Right, so what I need to do is, I know that for an equal angular triangle, it's going to be 60 degrees for all angles. Right, so I'm actually going to take a look at this right triangle right here. Right, so here, I know that this is a right angle and this is 60 degrees and this will be 30 degrees. Right. And if I cut an equilateral triangle with this height right here, and if this height makes a 90-degree angle, that's also going to cut the base in half. So I have my shortest side as 3. Right, so right here, from here to here, that's going to have a height of 3, or excuse me, a base of 3. And then using special right triangles, I know the height of this triangle right here is going to be 3 root 3. Right, so again, 3 root 3. So I want to find the area of this triangle. So that's going to be 3 times, so base times height. So my base is 3. And actually, let me highlight the area of the triangle that I'm looking at. So I want to find the area of this triangle right here, the one that I'm outlining in red. Divided by 2. Right, so here, the area of this red triangle right here is going to be base times height. So here I multiply 3 times 3 root 3. That's going to give me 9 root 3 over 2. And the other triangle over here, well, that's going to be the same as this triangle over here. So I simply double this. And you'll notice that my 2's cancel out. So the area of this entire triangle would be 9 root 3. All right. And then for the area of my 3 circles, all I have to do is I find the area of each semicircle and then multiply it by 3. So that's going to be 3 times pi times the radius. So the radius is going to be half the length of the base of the triangle, or one of the bases of the triangle. So half of 6, so from here to here. So this is my center, and then the distance from the center to the edge of the circle would be half of that, or half of 6. So my radius is going to be 6, or excuse me, 3. Right. Now remember, I can't simplify 9 root 3, so I'm just going to leave it as is. Right. So now we have 3 squared, which is 9, and then 9 times 3, which is going to be 27, pi over 2. Now, personally for me, I don't mind if you leave your answers like this. Obviously, if you don't have your units, just put units squared. But you can leave your answer like this. Now, obviously, it's going to depend on your teacher. But typically, I want to preface this. If you're talking about area, typically we like decimal answers. So I would put these numbers into my calculator. So 9 root 3 plus 27 times pi, which is 3.14, divided by 2. So this is going to be roughly 57.978 units squared. All right. Now you might get a slightly different answer. You might get 58 because I used 3.14 as my value for pi, you might decide to use the exact value for pi. And if you do that, so let me try that. So 9 root 3 plus 27 times pi divided. Yeah, you would get a number very, very close to 58. But again, I don't think it really matters to me, but typically when we talk about area, like if you were to go to buy a home, right, you want to know the square feet, you know, the area of the home, of the floor space. You wouldn't say, oh yeah, it's 9 root 3 plus 27 pi over 2 square feet. You would say it's roughly 57.978 or 58 square feet, right? So again, when we talk about area, we typically talk in decimal form. Right, so the last problem that we're going to look at is this figure right here. So you'll notice that we have three distinct figures. We have a semicircle. All right, so apologize for the crooked semicircle. We have the rectangle, and then we have our two triangles. Right, so again, following this pattern of just writing the formulas that I'm going to use inside my figures. And this one's going to be base times height divided by 2. So again, I substitute my figures or my values in for my formulas. So the radius of this semicircle is going to be half of 18. So that's going to be pi 9 squared over 2. Right. And then here for this rectangle, it has a base of 18 and a height of 8. So it's 18 times 2. And then plus 2 times the height of one of these triangles, which is 8, and then the base, which is 5. So it's going to be 8 times 5 divided by 2. Right. And if you were following along, you'll notice the 2's, they can cancel each other out. So I'm just going to go ahead and do that now. So I'm going to bring this down. So 9 squared is 81. And don't forget the pi. So it's 81 pi over 2 plus 36 plus 40. So if you wanted the exact answer for area, it would be 81 pi over 2 plus 76 feet squared. All right. Now it's up to you if you want to keep this in decimal form. Check with your teacher. All right. But again, you could simply plug these values into your calculator to get your decimal answer. So again, just to summarize, and I apologize for the screen getting cut off here. I can't adjust it mid-video. But again, basically you want to separate your figures. Draw your figures separately, and then draw your figure equation, right? And then substitute and then evaluate, and don't forget your units. So just going back to the last example, right? And then I keep forgetting to do this, but obviously this is your figure equation right here. Notice I drew the figures separately, right? And you could probably do this, especially if there's a lot of figures, you could probably put a check mark, right? Indicating that you got all the figures down. Because sometimes I've noticed in the past that some students, you know, they miss one of the shapes because there's like 7 or 8 different shapes. I noticed that they miss one of them. So sometimes you can just put a check mark. Okay, I got that, and then I got my 2 triangles. All right. So again, make sure you draw your shapes out, separate your shapes, write the formulas that you're going to use, substitute, and then evaluate, and don't forget your units.